Very good morning. Okay. So what we discussed in yesterday class? Anybody? In yesterday's class, what we
Potable
discussed?
water.
Tell me. Potable water, yes. So potable water, treatment of potable water. How many steps are present? How many steps? What is the first step? In treatment of potable water, how many steps are present? How many steps? And what are those? Please say, don't chart. 4 steps. What are those? What is the first step? The first step is screening. Yes. Present. Okay. Remember. Two not three. What is the first step in potable treatment of potable water? But net connection is very stable. Okay, tell me what is the first step in treatment of potable water? The first step is screening. Okay, and the second step is aeration. Third step, okay, now is it audible? Is it audible, ma? Okay. Treatment of potable water, in that 4 steps are present. First one is screening, second one is aeration, and third one is coagulation, flocculation, sedimentation, and last one is disinfection. Okay, first one screening, aeration, sedimentation, coagulation, flocculation, and last one is disinfection. Okay, so today's topic is breakpoint of chlorination. Today's topic is breakpoint of chlorination. So first of all, what is the definition of breakpoint? What is the definition of breakpoint chlorination? Why we have to do chlorination? Okay, so already you know how we kill the germs in water. We add some chemicals. Through that chemicals, we can kill that germs. Okay, so similarly, breakpoint of chlorination also. Okay, so breakpoint chlorination is a technique used to remove combined chlorine by adding free available chlorine. Okay, free available chlorine. To reach breakpoint, sufficient chlorine must be added to the pool to rise the free available chlorine level to 10 times the amount of combined chlorine. Okay, so breakpoint of chlorination means a certain point we can kill all the germs. Okay, that point is called breakpoint of chlorination. That point is called breakpoint of chlorination. So water contains the following impurities. See, so already you know what is water contains so many bacteria, organic impurities, reducing substances, and the last one is free ammonia. So reducing substances contains iron, hydrogen sulfide, etc. So these are the impurities present in water. So we have to kill those. How we kill? By using chlorine. Okay. So chlorine may be added to water directly as a gas or in the form of a bleaching powder. When chlorine is applied to water, the result obtained can be depicted graph. The graph shows the relationship between the amount of chlorine present in water and the residual chlorine. Okay, residual chlorine. So you can observe this graph. So this is a residual chlorine and addition of chlorine. Okay, so just imagine it is a water pool. Okay, just imagine it is a water pool. So if you add 2% of chlorine, if you add 2% of chlorine, after some time, the chlorine all dissolved in water. Okay, so there is no residual chlorine. Means there is the chlorine was not left. So total chlorine is completed. Okay, so but the gems, I mean gems or bacteria, organic impurities was not vanished. Okay, so but here there is no residual chlorine. Okay, so that's why here there is no graph increases. Okay, so this graph indicates residual chlorine, addition of chlorine. Okay, so later you can add some more amount of chlorine. Okay, so first you add 2% of chlorine, later you add 3% of chlorine. Okay, so if you add 3% of chlorine, so here some germs are killed. At the same time, some residual chlorine also present. Some residual chlorine also present. Okay, so later again, but some bacteria, microorganisms, and all impurities also present. Okay, so later if you add the some more amount of chlorine, so here less amount of residual chlorine is present, so that's why the graph decreases. That's why the graph is decreases. Later if you add the some more amount of chlorine, so here it is this point is called break point of chlorination. Means it kills the all germs and microorganisms. Okay, so when certain point it kills the all germs and microorganisms, and it removes the all residual all organic matter. That point is called break point of chlorination. Okay, so first you have to add the chlorine. So step by step we have to increase the chlorine. Okay, so here 3%, if you add the 3% of chlorination, here some residual chlorine is present. That's why the graph was increased. Later you can add the some more amount of chlorine. So the graph, so here less amount of residual graph, less amount of chlorine is present. That's why the graph was decreased. Again you can add the chlorine. Okay, so at this point is called break point of chlorine. So if you so after adding these step by step, so here there is no bacteria, there is no germs, there is no organic impurities. Okay, so this point is called break point of chlorination. Okay, so it is seen from the graph that initially the applied chlorine is used to kill the bacteria and oxidizes all the reducing substances present in the water, and there is no free residual of chlorine. There is no free residual chlorine. Free residual chlorine means some amount of chlorine was present. That is for that residual chlorine there is no use. Okay, as the amount of applied chlorine increases, the amount of combined The amount of combined residual chlorine also increases. This is due to the formation of chloramine and other chloro compounds and other chloro compounds. So at one point on further chlorination, the oxidation chloramines and other impurities starts, and there is a in the combined chlorine content. Chlorine decreases minimum point at which oxidation of chloramines and other impurities complete and free residual chlorine begins to appear. This minimum point is known as breakpoint of chlorination. So, step by step, after adding step by step adding chlorine, we can understand certain point we can clear all germs and bacteria and organic impurities, all we can tarnish. Okay, that point is called break point of chlorination. By adding chlorine we can remove all these. Okay, so when you kill the these impurities certain point, okay, that point is called break point of chlorination. Thus this eliminates bacteria, reducing organic substances responsible for the bad taste and odor from the water. So this is the graph for breakpoint of chlorination. This side indicates residual chlorine and this side indicates addition of chlorine. So this is the graph. It is very important breakpoint of chlorination, and graph also very important. And next one is see. So what happens after breakpoint of chlorination? What happens when more chlorine is added? The past the breakpoint, the chlorine reacts with acid in the proportion to the amount of chlorine added. The proportion of chlorine is added. The combined chlorine level is calculated by subtracting the free chlorine. So combined chlorine we can indicate Cc, okay, and the free chlorine we can call Fc. From the total chlorine we can call Tc in the pool. Okay, what is the importance of breakpoint? What is the importance? We can eliminate the organic impurities. Okay, breakpoint chlorination eliminates the chloramines and other reductants which otherwise cause an increased chlorine demand in the water. The principal purpose of breakpoint of chlorination is to ensure effective disinfection by satisfying the chlorine demand of water. Next topic is internal treatment of boiler fed water. Internal treatment of boiler fed water. Okay, so internal treatment is the scale forming substances which were not completely removed in the external treatment by adding chemicals directly into the compounds. So we have to remove the impurities. Okay. So if it is not possible through external treatment, so we can go for internal treatment of boiler fed water. Collagen conditioning. Next topic is collagen conditioning. These substances interacts. Okay. Okay. Collagen conditioning. So what is the collagen conditioning process? Collagen conditioning, it is the process of addition of collagen or sodium hexametaphosphate to boiler fed water. So the calcium ions responsible for scale or sludge formation are complexed by collagen to form a soluble complex and hence prevented from their scale forming action. Okay, so by adding, so collagen conditioning means it is the process addition of collagen. Collagen, what is the chemical name? Sodium meta, sodium hexa metaphosphate. Okay, collagen compound name is sodium hexa metaphosphate. So these compound we have to add into the boiler fed water. So it removes the calcium ions. Okay. So what is collagen and why collagen conditioning is preferred? Why we have to prefer this condition? The add collagens form soluble complexes compound with calcium sulfate. With calcium sulfate, thereby it prevents the scale and sludge formation in water. The soluble complex does not cause any problem in boilers. Hence, collagen conditioning is better than phosphate condition. Okay, so it is better than phosphate condition also. Okay, so how does collagen conditioning prevents scale formation? So collagen means sodium hexametaphosphate. The process involves addition of addition of sodium hexametaphosphate to boiler fed water. It prevents the scale and sludge formation by forming highly soluble calcium hexametaphosphate complex compound with calcium sulfate. Okay, so what is collagen means? Hexa meta, sorry, hexa sodium hexametaphosphate. What is made from collagen? The original product consisted of powdered sodium hexametaphosphate. Okay, powdered means it resembles like a amorphous sodium. So amorphous sodium polyphosphate, which in water would complex with ambient calcium ion and certain other cations, preventing formation of unwanted salts and interference by those cations with the actions of soap or other detergents. Okay, so you can observe this reaction. Calcium sulfate reacts with collagen. It forms the sodium compound and sodium sulfate. So these complex NO2, sorry, Na2NO4, no, NO2 NO4 PO3 6 means sodium hexametaphosphate. So here we have to change this equation Na2 here also. Na2. Na2 NO4 PO3 6 means sodium hexa means 6. Metaphosphate is soluble in water and there is no problem of sludge disposal. So collagen conditioning is better than phosphate conditioning. And next one is phosphate conditioning. And next one is phosphate conditioning. The scale formation can be avoided by adding sodium phosphate. It is uh, it is used in high pressure boilers. The phosphate reacts with calcium and magnesium salts to give soft sludges of calcium and magnesium phosphates. So you can observe phosphate conditioning means we have to avoid the sodium phosphate. It is used to high pressure boilers. Okay. So phosphate conditioning where we have to use high pressure boilers. The phosphate react with calcium and magnesium salts and it gives the soft sludges of calcium and magnesium phosphates. So you can observe this equation. Calcium sulfate react with sodium phosphate. It forms the calcium phosphate and sodium sulfate. Okay. And next one is generally phosphates are three types. Those are trisodium phosphate. So tri means 3. Here Na3PO4. 2, it is a 2 alkaline and it is used for acidic water. So if the phosphate conditioning is very alkaline, we have to add into the acidic water. So if you add the acidic water, it will be neutral. Okay. So if you okay, phosphate is basic in nature. So we have to add the acidic water, then it will be neutral. And next one is disodium hydrogen phosphate. Di means here 2 moles of sodium. Okay. So HPO for disodium hydrogen phosphate. So it is a weakly alkaline. So we have to add in weakly acidic water. Weakly acidic water. And next one is sodium hydrogen phosphate. Next one is sodium hydrogen phosphate. So this sodium hydrogen phosphate, it is very acidic in nature. So that's why we have to add into the alkaline water. Okay. And next one is colloidal conditioning. Next one is colloidal conditioning. So colloidal conditioning means colloidal conditioning, it is a formation can be avoided by adding colloidal conditioning agents like kerosene, agar, gelatin, etc. Okay. So these are the chemicals. Okay, these are the chemicals in colloidal conditions. What are the chemicals we used in colloidal condition? Kerosene, agar, and gelatin. Okay, so why we have to use colloidal condition? To avoid the adding of colloidal. To avoid the okay. So it is used in low pressure. It is used in low pressure boilers. So phosphate conditioning, boiler fed water, phosphate conditioning, it is used in high pressure. Colloid, colloidal conditioning, it is used in low pressure boilers. These colloidal substances get coated over the scale, forming particles and convert them into non-adherent loss participate called sludge, which can be removed by blow down operation. Blow down operation. So here, colloidal conditioning in chemistry purpose, it is a mixture of in which one substances of microscopically dispersed insoluble particles is suspended throughout another substances. The dispersed phase particular particles or droplets are affected largely by the surface chemistry present in the colloid. So what are the colloids examples? What are the colloids examples? So the colloidal substances get coated over the scale forming particles, and thus the coalescence of these particles to a compact scale is prevented. Thus, the scale formed remains loose and non-sticky and can be easily removable. Okay. So what are used in colloidal conditioning? So we can use colloidal conditioning. What are those chemicals we used? Kerosene, agar-agar, and another one is gelatin. Okay. So these are colloidal conditioning. So which conditioning method is used to for internal treatment? Internal treatment. So these are two general approaches: conditioning inside boiler by coagulation or dispersion when total amount of sludge is high. As a result of high fed water hardness, it is better to coagulate the sludge to form large flocculent particles. These can be removed by blowdown. Okay. And next one is desalination of brackish water. Desalination process of removing common salt from the water is known as desalination. You know the meaning of saline water? Saline water is nothing but salt water. So in the name only present desalination. Desalination means we have to remove the salt. So that process is called desalination of brackish water. The water containing dissolved salts may be a peculiar salty or brackish taste is called brackish water. Okay, so it means more amount of salt present in the water. So that's why we have to remove the salt. That process is called desalination. Okay. So depending upon the quantity of dissolved solids, water is graded as fresh water contains less than 1000 ppm of dissolved solids. Okay, fresh water contains less than 1000 ppm of dissolved solids. Okay. And next one is brackish water. Brackish water contains greater than 1000 but 35,000 ppm of dissolved solids. Seawater contains 35,000 ppm of dissolved solids. Solids are not salts. Seawater and brackish water can be made available as drinking water through desalination process. Desalination is carried out either by reverse osmosis or electrodialysis. Okay, so either so desalination means removal of removal of salts. Okay, saline. What is the meaning of saline water? Salt water is nothing but saline water. So desalination means removal of salts. Okay. So brackish water is treated with through desalination. Desalination process is a process that removes dissolved mineral salts from saline water and converts it into fresh rum saline water and converts it into fresh drinkable water. Okay, so fresh we can drinkable water. So what are the process? Reverse osmosis and distillation are the primary desalination technologies used to treat brackish water. Okay, brackish water means it contains more amount of salts. Okay, what is the amount of brackish? Greater than 1000 to 35,000. Seawater contains greater than 35,000 ppm. Presents the salt. Okay. How do you purify the brackish water? By using reverse osmosis for purifying the brackish water. Okay, how we have to remove the brackish water means by using reverse osmosis. So is a titration method purify brackish and salt water. The RO system provides the most extensive filtration because the RO means reverse osmosis. Okay, so reverse osmosis membrane has the smallest pore size, rejecting the salts, fluoride, and dissolves water. Okay, can brackish water be treated? So for purpose requiring lower dissolved solids content, especially drinking water, brackish water is treated through reverse osmosis or other desalination process. Why is brackish water bad? Why is brackish water bad? Why? Because the brackish water contains more amount of salts, right? So it is a very salty character. So you cannot drink brackish water because of its salty character. If you drink salty water, what happens? Your kidneys will overproduce urine in order to expel the excess salt from your body, leading to dehydration. However, when desalination and treated brackish water is safe to drink, okay, so then only we have to drink. Okay, so after reverse osmosis, we can, after reverse osmosis of the brackish water, we can remove the all salts. Okay, so next, do what is the natural desalination? What is natural desalination? So desalination means removal of salt, right? So evaporation of water over the oceans in the water cycle is a natural desalination process. The formation of a sea ice produces ice with a little salt much lower than the sea water. Okay. What are the two main types of desalination? Two main types is there. Two, two, two desalination technologies are used primarily around the world desalination. One is thermal desalination and another one is membrane desalination. One is thermal desalination and another one is membrane desalination. Is desalination expansive? Is desalination is expansive? Seawater desalination is one of the most expansive sources of fresh water because desalination requires a lot of energy. The plants are also very expensive to maintain. Okay. Okay, all of you say the answers. Now I'll ask questions. Okay. So what is the meaning of breakpoint of chlorination? What is the definition of breakpoint of chlorination? If you say the answer, I will give present. If you didn't say the answer, I will give absent. Okay. So what do you understand? Breakpoint of chlorination. Say. Charan Sai. What is the meaning of breakpoint of chlorination? 243. Pranaya, Sai Pranaya. 244. Rashid. Here. Breakpoint of chlorination. What is the definition of breakpoint of chlorination? Is there all? Say yes or no. This is also. So breakpoint. What is the meaning of breakpoint? So thus the combined residual chlorine decreases to minimum point at which oxidation of chloramines and other impurities complete and free residual chlorine begins to appear. This minimum point is known as breakpoint of chlorination. Okay, this is the graph for breakpoint of chlorination. Okay. So internal treatment of boiler fed water. Why we have to do internal treatment of boiler fed water? If if you doesn't remove the impurities by using external method, we can go internal treatment of boiler fed water, right? So we cannot remove by using external treatment. We can go for internal treatment only. Next one is collagen conditioning. Next one is collagen conditioning. So here we can remove the scales and sludge formations in the water to avoid that one. So what is the collagen? Chemical formula? Sodium hexametaphosphate. Okay. Phosphate conditioning. So it means here phosphate conditioning. So phosphate conditioning means here we have to react with the, so phosphate react with the calcium sulfate, we can get the compound, sodium compound and sodium sulfate. So phosphate is those are trisodium phosphate and another one is disodium sodium dihydrogen phosphate. Trisodium phosphate is a two alkaline, that's why we have to add in the acidic water. And next disodium hydrogen phosphate, it is a weakly alkaline, so we have to add in the weakly acidic water. Okay. So sodium dihydrogen phosphate, it is acidic in nature, so we have to add into the alkaline water. Okay. And next one is the colloidal conditioning. Last one is the brackish water. Okay. So all